My dear students, let us discuss optical isomerism. It is another kind of stereoisomerism. Optical isomerism is defined as same molecular formula, same structural formula, but different behavior towards plane polarized light, PPL, plane polarized light. This is what we call the optical isomerism. Okay. Yes. Optical activity. Optical activity. Optical activity. It is the property of optically active molecules. It is a property of optically active molecules which rotate plane polarized light either in clockwise or anti-clockwise direction. Either in clockwise or anti-clockwise direction. This is called optical activity. Optical isomerism is the property of the molecule having same molecular formula and same structural formula, but they have different behavior towards plane polarized light. What is that behavior? The behavior is that rotate the plane polarized light either in clockwise or anti-clockwise direction. Now, what is this? Let us explain in detail. Okay. Yes. This is an ordinary light. A light from a bulb. Okay. This is ordinary light. What is this? These are the radiations or light rays which are propagating in all directions. Therefore, in an ordinary light, suppose you hang a bulb in a room, you will get the light in the entire room, not only in the direction of hanging. Or if you keep a bulb here or here, you will get the light in every direction because light radiations are propagated in all directions. That is the ordinary light. Now this ordinary light has been passed through a prism, nickel. We will say that nickel prism or calcium carbonate, calcite, like that. Okay, your ordinary light become monochromatic. You will get a monochromatic same wavelength, same direction, monochromatic or plain polarized light. After passing through Nicol prism, you will get an ordinary. That is, it propagates only in one direction. It propagates only, not only one. This is one direction, like that. Okay. Now you see only the blue pen, but there are pen again below, behind this blue. You will get a plain polarized light like this. Okay, it comes like this. Fine, it comes like this. But an ordinary light like this, it has all directions. This has been cut off. This has been cut off. Now you have only this light. Okay, it comes like this. Okay, fine. Okay, now you pass this light through a solution of this is nothing but a solution of optically active compound, okay. Then you observe the light. Suppose this is what is we called a polarimeter. Now you observe the light which come out of this solution. You observe the light through a polarimeter. That light is coming out of this solution. The light entered here and it come out. The light is just passed through the solution. Then you observe. You have two options. You have two options. Okay. You have two options. Let us see what are the options. Option number one, it was the actual direction of your ordinary light. But that ordinary light has been now this way. Two options. It can be this way. This way means, imagine it was like this, just rotated in this direction. It was like this. Okay, just rotate. It was like this. Okay, it just rotated like this. This is called anti-clockwise rotation. This is clockwise rotation. Or there are two options. Maybe this light might have rotated this way or this way. That is anti-clockwise, or left or right. Fine. This is what our optically active compound is doing. Okay. Now, optically active compound may be dextrorotatory or levorotatory. It will be dextrorotatory if the rotation is clockwise. It is levorotatory if it is anti-clockwise rotation. Therefore, The molecule will be two option, may be dextrorotatory or levorotatory. If the molecule has rotated the light in anti-clockwise, you call your molecule is dextrorotatory molecule, sorry, levorotatory molecule. If it has rotated in clockwise, you can call it your molecule as what I am calling dextrorotatory. There are this is plus sign or D, minus sign or small letter L. Very careful, small letter L. Okay. Therefore, what is dextrorotatory molecule? What is levorotatory molecule? Optical active molecules are two types. Optically active molecules, two types. One is dextrorotatory molecule. Second is levorotatory molecule. Rotatory molecule. What is dextrorotatory molecule? The molecule which rotate plane polarized light in clockwise direction. It rotates plane polarized light in anti-clockwise direction. Anti-clockwise direction. It is called plus molecule. This is minus molecule. Or D molecule. This is L molecule. Okay? Yes. This is the basic understanding of or introduction of optical activity and optical active molecules. Therefore, we have two types of optically active molecule, dextrorotatory molecule and levorotatory molecules. Fine. Now, the magnitude of rotation depends upon magnitude of rotation depends upon first nature of substance. Second, concentration of substance. Third, nature of the solvent. Fourth, length of polarimeter tube. Fifth, temperature of experiment. At which experiment you are doing the at which temperature you are doing the experiment. The rotation, magnitude of rotation depends upon all these, and I think one more factor is there, wavelength of light. Wavelength of monochromatic light. Okay. Yes. Okay. Now, conditions showing optical activity. Which molecules are optically active? What are their conditions? Okay. Basically, there are two conditions. First is there should be at least one chiral center. Second, molecule should have non-superimposable images. Third, it shouldn't contain plane of symmetry or center of symmetry. Should not contain plane of symmetry or center of symmetry. This is the primary condition. There should be at least one chiral center. So there are certain molecules which are optically active even if they have no chiral center, because they satisfy these two conditions. Now let us discuss what is a chiral center. What is a chiral center? Chiral center. Normally it is a sp3, very important, sp3 hybridized carbon. In certain case nitrogen also, nitrogen, phosphorus, etc. sp3 hybridized carbon containing 4 different atoms or groups. That's all called chiral centers. It is also called asymmetrical center. Asymmetrical center or chiral center or chiral carbon. Different names are there. Let us take some example. CH, D, CH3, CH2, CH3. Because 4 groups A, B, C, D all are different. This is deuterium, this is hydrogen. This is methyl, this is ethyl. Another one, H, Cl, Br, iodine. If I write like this, OH, this is a chiral center. Here is a chiral center. Why? Because this is CH3, this is CH2, CH3, this is OH, here a hydrogen. Okay. Another one, look at here. OH. This carbon is chiral. You know why? Because this carbon, there is hydrogen, CH2, 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 CHOH. Look at here. This carbon is chiral because this is A group, these are B, this is C. I'm really sorry. Here one more hydrogen. I'm really sorry. This carbon, look at this carbon. I have really sorry. Here one Cl. I just give you here Cl. Therefore here Cl. here Cl. This is a chiral carbon because here a hydrogen. Look at here, I am really sorry, there is a small mistake. Now this is a chiral carbon because here A, B, this is C, and this is T. Okay, therefore this carbon is chiral. This is the general picture of the chiral carbon. We will have a lot of examples like this. Okay, you have to able scan the chiral carbon as quickly as possible. Okay, now there is non-superimposable mirror image. Superimposable mirror image. What is that? Actually, it is a property of chiral molecule. Every chiral molecules have non-superimposable mirror image unless they have center of symmetry or plane of symmetry unless they have center of symmetry or plane of symmetry. I will tell you one simple example. Suppose you write P. You have a mirror here. How the P will be observed in the mirror? Tell me. Suppose this is a mirror. This is the P. Now you take the P from here, pick the P from here and bring like this. It will be a non-superimposable mirror image because that P like this. Okay, you just pick and put like. Therefore, this is called a non-superimposable mirror image. Okay, this is a property of suppose you have an S. This S will be. Suppose this is a mirror. This will be like this. A B, imagine your B will be like this. You pick the B from here or you pick the S from here, it will be like this. Therefore, it is not a superimposable. What is superimposable? I will tell you some example of superimposable mirror image. Suppose you take O. This is a mirror. This is also O. You pick the O, superimposable. You have an A. What is a mirror in the like this? You just pick this superimposable. Therefore, these are the superimposable images, but these are PSB are non-superimposable. Therefore, optically active molecules are non-superimposable mirror images. Optically active molecules have non-superimposable mirror images. They have no chiral centers. They have no center of symmetry or plane of symmetry. Okay, this is all about. I just give you some example for chiral center. How many chiral centers are here? Just how many chiral centers? Chlorine, another molecule. Okay. In this case, you just write like this: CH3. This is CH3, C double bond O, CH, Cl, CH3. This is not chiral. CH3, C double bond are not chiral because it is sp2. CH3 is not chiral. Only this one is chiral. This one is chiral. Okay. Now you write this molecule CH3, CH2, 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 CH3, CH3. This is not okay. This is not okay. CH2, CH not okay. Now you have this option. Okay. How many chiral centers this molecule? Now you just make this H. This is second group. You can make this third group. You can make this fourth group. Therefore, these are same. Therefore, this is also not the chiral. This is also not the chiral. But when you come here, this molecule, this is chiral because this side is different from this side. Similarly, this is chiral. This is chiral. This is also chiral. This is also chiral. This is also chiral. Okay. And this also chiral. Okay, this carbon is chiral, 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 this. Therefore, there are 7 chiral centers. But this is not because it is sp2. sp2 are not chiral. This is CH2. This is CH3. This is CH3. This is CH2. This is CH3. This is CH3. This is CH3. This is CH2. These are not chirals. CH3 and CH2s are not chiral. Okay. These carbon are not chiral because all are sp2. sp2 not chiral. Okay. Therefore, this is the introduction of optical isomer. We have discussed what are the chiral centers, what is optical activity, what is a plane polarized light, what is a rotation, etc. etc. Okay, we will continue in the next video. Thank you.